Elimination is a third method of solving a system of linear equations. So in this video, we're going to go through steps on how to use the elimination method to solve a system. There are 3 steps in solving a system of equations using elimination. Step 1, you're going to write a system so like terms with opposite coefficients are aligned. What that means is, if you look at our example here, I have 5y, a positive 5y, and a negative 5y in the other equation. The reason why that is important is so that you can eliminate one of the variables. Step 2, you're going to add the equations, eliminating one variable, and then solving for that equation. And then step 3, you're going to substitute the value from step 2. So whatever we got for that one variable, we're going to put that answer in for that same variable in one of the 2 equations so we can solve for the other variable. Now, using elimination, it would be best if it's in the standard form, so then you can line up the variables with that. So that would be my first step, just make sure that the x and y variables are on the same side. So here, in example 1, everything is lined up. I look at all my coefficients. I have 3x and 5x. They're not the same. I have a positive 5y and a negative 5y. They have the same coefficients but opposite signs. That is what I want so that I can eliminate my y's. So then all I'm going to do is add straight down. So now I have 3x plus 5x. 3x plus 5x is 8x. The y's cancel off. And then this is going to be 11 plus 5, which gives me 16. Now I have one simple equation left. The opposite of multiplying by 8 is dividing by 8. So if I divide everything by 8, I'm left with x equaling a positive 2. Now I'm going to take that answer and substitute it into one of the 2 equations above to determine what my y value is going to be. Now it doesn't matter which one you use. I'm just going to use the bottom one this time. So I'm going to have 5 times my x, which we found was 2, minus 5y has to equal 5. So this gives me 10 minus 5y equals a positive 5. I'm going to subtract 10 on both sides. And this is going to be, and I'm going to put this over here. I have negative 5y equals 5 minus 10 is a negative 5. To get y by itself, I'm going to divide by negative 5. And I'm left with an answer of y equaling negative 5 divided by negative 5 gives me a positive 1. So you can either write your answer as x equaling 2 and y equals 1, or you can write as an ordered pair 2, positive 1. Just keep in mind, if you do write it as an ordered pair, make sure you write it in the correct order where the x coordinate goes first and then the y coordinate. Our second example. Here we have 3x plus 6y equals 30 and 5x plus 6y equals 6. Now here, you'll notice that the y's have the same coefficients and the same equations. So here we're going to eliminate by using subtraction. So we're going to multiply one of the equations by a negative 1 so that we can simplify what we have, or eliminate one of the variables. So what I'm going to do is I'm going to multiply this bottom one by a negative 1. And I'm going to write everything to the right here. So the top equation stays the same as 3x plus 6y equals 30. The bottom, I'm going to distribute a negative 1, which makes that negative 5x. Negative 1 times 6y is a negative 6y. And negative 1 times 6 gives us a negative 6. And then we just Combine like terms straight down, so 3x minus 5x is a negative 2x. The y's cancel off, and I'm left with 30 minus 6, which gives us 24. Negative 2x equaling 24, the opposite of multiplying by negative 2 is divide by negative 2. And I have an answer of x equaling x equals a negative 12. Now to find my y, I'm going to take my x and I'm going to substitute it into one of the two equations above. Again, it doesn't matter. I'm going to choose the top one. So I have 3 times negative 12 plus 6y equals 30. 3 times negative 12 is negative 36 plus 6y equals 30. To get 6y by itself, I'm going to add 36 to both sides. And I'm left with 6y equaling 66. And the opposite of multiplying by 6 is dividing by 6. 66 divided by 6 gives me an answer of y equaling a positive 11. So my answer would be x is negative 12, y is positive 11. And we have one more example. This one requires a little bit more work because they don't have common coefficients. So you're going to have to multiply both equations by a number so that you can eliminate one of the variables. So step one, you're going to multiply at least one equation by a constant to get two equations that contain opposite terms. Then steps 2 and 3 are going to be the same as all the other ones, where you're either going to add the equations or subtract the equations to eliminate one of the variables, and then substitute that answer in for a variable to solve the other variable. So here I have 3x plus 4y equals negative 22, and negative 2x plus 3y equals negative 8. Now for me, when I look at and I see that there's no common variable or common coefficient, I look at the ones that have opposite signs. I see that the coefficients for x have opposite signs, so I'm going to eliminate the x's here. Now, do you have to do that? No, you could still eliminate the y's. The only thing is you have to remember that you'll have to multiply one of the equations by a negative number. So here I have 3x and negative 2x. I know that they both have a common multiple of 6. So I want to multiply this top equation by 2. So if I distribute a 2, that's going to give me 6x. 2 times 4y is a positive 8y. And 2 times a negative 22 gives me a negative 44. And now my second equation, since the top one has a positive 6x, I want to make this a negative 6x, so I'm going to multiply this bottom one by a positive 3. 3 times negative 2x is a negative 6x. 3 times 3y is a positive 9y. And 3 times negative 8 equals a negative 24. Now I combine like terms. So really I'm just going to be adding straight down. So the x's eliminate. 8y plus 9y is 17y, equaling negative 44 plus a negative 24 gives us a negative 68. And then if I take negative 68 divided by 17, I have an answer of y equaling a negative 4. Next, I'm going to substitute that negative 4 in for y in one of the two equations. Again, it doesn't matter which equation. I'm going to use the bottom one just because it has smaller numbers. So I have negative 2x plus 3 times negative 4 equals a negative 8. So I have negative 2x minus 12 equals a negative 8. I'm going to add 12 to both sides. Now I have negative 2x equaling a positive 4. To get x by itself, I'm going to divide by negative 2. I'm now left with x equaling a negative 2. So that is how you can use elimination to solve a system of linear equations.